Yeah, welcome everybody. My name is Lorenzo, and together with Andrea here, we're gonna talk you through our journey to standardize machine learning operations at a startup, and we will give a quick example of that using Dagster and PyTorch. And so this is it's a PyData track, so we'll assume most of you know about PyTorch. But what about Dagster? How many of you have heard about Dagster? What is this, like 20%? How many of you have used Dagster? I win. All right. First thing first, we are from Overstory. Overstory is a startup that has been around for about 3 years now. It's a group of around 30 people all over the world. What we do really is we use satellite images to monitor vegetation. In particular, the problem that we're trying to solve, it's depicted very well in this picture, so I'm not sure you can see super well, but it's a tree that has fallen on a power line. So trees that fall on power lines, of course, they cause issues to the person that is on the other end of the power line. You get no more electricity. But most importantly, it's a big cause of wildfires. So what we try to do is we help utilities manage the vegetation around the power lines. And how do we do that? It's much more complicated than that, but in a nutshell, we acquire satellite images, and not just any satellite images, we use very high resolution satellite images. So there are these super awesome constellations out there of satellite that can image the Earth down at like 50 centimeters, 30 centimeter resolution. So it's quite hefty data if you have to do it on thousands of miles of a utility. We process it with our pipelines to extract things like the health of the vegetation. So if a tree is dead, of course, it's more likely to fall when there's a strong gust of wind. We do things like the height of trees. We do things like the tree species. And then we combine this layer with open data, for example, the slope of the terrain, and then, of course, the customer-specific layers. And we put all of this in what we call the risk score. And this is like a tool that teams on the ground can use to plan their trimming cycles. So what area should we prioritize? Because they really manage thousands of kilometers of power lines. So what we want to talk to you about, it's basically how we tame chaos. And this is my CTO that actually suggested this phrase. We are a startup that it's building its product while really learning what the product is from our clients. And also other small things like building a team. So there's a lot of moving parts. We have data that changes. We iterate constantly on what kind of satellite images we use, and they're all different. They're all acquired in different ways, processed in different ways. The technology changes. We have switched cloud providers. We constantly iterate on what kind of storage services for the different pipelines we use. The use case changes. So as we learn more, we might have to use different models with different outputs all the time. And I think actually the most important thing that changes is the team. So we have gone at Overstory from a team of 3 people in the tech team around 2 years ago to about 15 people now. So of course the team dynamics change. And then most importantly, we keep on hiring people that are smarter than us. So we don't want to build something that, when the next kid comes on board, it says, oh, but wait, we should do it differently, and then we don't use this anymore. So we want something that is flexible enough to sort of adapt to all this change, but at the same time, give us a little bit of a structure. Most of us here are engineers, so you understand what I mean. Who are we? My name is Lorenzo Riquez. I'm a data scientist at Overstory, so I do all things satellite data processing and machine learning. Andrea, you want to say hi?
Yeah. Hello, everyone. My name is Andrea Giardini. I'm a freelance cloud-native consultant and trainer. Been working with Lorenzo at Overstory for almost a couple of years now.
So how are we going to do this? We're going to quickly show you what a simple inference pipeline looks like with satellite images. How do we port that to Dagster? So we're also going to tell you what Dagster is. How do we deploy that in our production environment? And then finally, sort of what is the infrastructure that is needed to support all of this? So from the beginning, a very simple inference pipeline that we might use, it's what we call a canopy segmentation inference pipeline. What goes in are satellite images. Again, these are very high resolution satellite images. To give you an idea, these are about tens of thousands of pixels wide, tens of thousands of pixels tall. They usually have more than 3 bands. So if you work with images, many times you're used to the RGB visible spectrum, but there are other frequencies that we don't see that interact very well with vegetation, for example. So we use a bunch of those. And the output, what we want is a mask that tells us for every pixel, basically, if we have a tree or there's another tree. And this is like a building block for many of the pipelines that we build. We have 3 modules in here. We have the data loading component. So how do we load bits of the satellite image, process it, feed it to the model? So that's the X. We have the model itself. It's going to be a convolutional neural network. So we need to instantiate the graph and sort of the weights of that model. And then finally, how do we put these things together? So how do we iterate over the satellite image, run it through the model, and then save to our output? A note, we have only productionized our inference part. We're not talking about training here. Training, currently Overstory, it's totally the land of freedom. So the reason is because we don't really build models that quickly. We might put a new model in production every couple of weeks. And also training, it's a little bit of an art still. So we want to leave the freedom to the data scientists to use the frameworks they want, whatever tools they want to use notebooks, they want to use scripts, whatever. What's important is that once you want to share that model with the rest of the team, there's a structure to do that. And this is why we automated the inference component. Okay, I'm going to skim through these, some simple PyTorch routines to do these steps. Loading of the data, the X. With PyTorch, you do this with the Torch dataset class. Probably many of you are familiar with it. So we define this geotiff dataset class. And what's important here is that get item method. So whenever you give an index of a place within the satellite image, we return a single sample of that we actually load into memory. So we use a library called Overstory to do that, to work with the satellite image. And we only load, you can see there a window, so a portion of the satellite image. For example, we could be loading only 256 by 256 pixels to feed it to the model. We're not going to feed the entire satellite image to the model. And we can also select the number of bands that we put in. So do we just want 1 band? Do we want all the visible spectra? Do we want more bands? So we can also decide on that. So this is our data loading. The model definition, we use here a library called Segmentation Models PyTorch. The acronym is SMP. We define a UNet with a ResNet34 backbone. Nothing important. What's important is the input classes here. We have 4 input classes, so we're going to select the 3 bands from the visible spectrum plus 1 extra band. And we have 2 output classes, so whether something is a tree or not a tree. We assume our data scientist has trained its model, saved the weights locally, so we load these weights and we can plug it into the network. The inference routine, so how do we put these things together? The only thing that we care about right now is how we iterate over the bits of the satellite image, load them, run them through the model, the forward pass of the model, and then save these outputs to our output. The fun part. So how do we port that to Dagster? We're going to talk about Dagster in a minute. What you need to know right now are 2 concepts of Dagster. Basically, what are ops and what are graphs. So ops will be the steps of your pipeline. So these are individual bits of work, like loading some data, calling an API, running a notebook, whatever. So we have those 3 modules that we talked about, the X, the F, and the F of X. We're going to opify all of them. So let's take example. There's a little bit of code at the top, this canopy dataset function. This will be our op that does the X, so that loads the data. All we do here is just we instantiate that geotiff dataset that we saw before. How do we make Dagster know that this is an op, so a step in our pipelines? We just add this little decorator, op, and that's all we need to do. So this becomes an op that is available to any graph later on. We can pass a bunch of things to it. Here, for example, I put the valid indices. So this is just defining the data type of our input parameter. Dagster will do type checking automatically before you run the pipeline. So let's assume we have opified these 3 building blocks of our pipeline, the x, the f of x, and the f. And now let's build our pipeline. So that's the second concept of Dagster, graphs. This is how we combine ops together into a graph. So if you see here, this is this canopy segmentation function. And in here, you can actually see the model. So that's the f. So that's the op that loads the model. The x. So this is the op that loads our data. And then the f of x, this is the op that runs, that does the f of x, let's say. As you can see, we can pass data between ops very easily. So that's also a mega bonus. How do we make Dagster know that this is our graph? Again, decorator, graph, that's all you need. We can specify a bunch of things again. There's some tags here. What you need to look at is, for example, the standard. So this is how we allocate resources to our graph. So standard, for example, for us is a standard machine in our Kubernetes infrastructure. So this is how I supply the let's say, the hardware requirements, resources to our pipeline. And this is done. We have effectively ported our code to Dagster. The last bit from the data scientist point of view, which I think it's really awesome and why we really love it as data scientists at Overstory, is that Dagster allows you to do things locally in the same way that you do it on your production Kubernetes, whatever environment. So we define here test canopy segmentation. This is going to be a simple test. So we can test any op, any graph, whatever. So we test here basically our graph. We just put some configurations in the YAML file, and then we just run the job that we created just before, that canopy segmentation job, with this configuration. And all we do is just we check on the output. So we check, for example, that the output is, I don't know, 256 pixels wide. And I can, as a data scientist, I can, on my machine locally, execute this in the same way that my CI will then execute it later on in some other infrastructure. Yeah.
Okay, so what now? Now our data scientists created their own pipeline, they have their own code, they have opified or Dagsterized their pipeline, and I would say that we are ready to push it to the cloud and make it scalable, right? Well, let's take a step back. Let me give you a more, a longer introduction about Dagster. There will just be a couple of slides. Dagster is a tool that does workflow management, basically. It's comparable to other tools out there like Airflow, Prefect, and so on. You might be familiar with some of those. It's an open source project. It has been around since a couple of years, but it's still really young and it's moving continuously. Just to be 100% clear, myself and Lorenzo don't work for the company of Dagster. We are part of the community. We're just really enthusiastic about their product. So this is not a sales pitch, so don't run away, please. It has a very nice integration with Kubernetes and the cloud. This is something that I really appreciate as a cloud engineer, let's put it this way. And it has a very nice, smooth web interface that our data scientists, but also people from the product side, for example, can see and check if our pipelines and workflows are working correctly, if the last pipeline was successful, and so on. Let's have a look a little bit more in detail. What are the components that made Dagster, and how does that work? So Dagster is made by a few different components that are represented in this slide. The two main components are the Dagster daemon. As you can imagine, this is just a simple, not really, but it's a background service that basically checks which workflows need to be run and executes them for you. If you're running them in Kubernetes, it will run them in Kubernetes. If you're running them locally, it will run them on your local machine. You can run them on Docker if you wish. So depending on the platform where you are, Dagster will execute the appropriate command and steps. Next to it, you can see we have the Dagit web interface. This is a web interface that allows our data scientist, data engineer, also product to see the pipelines that are currently running, which one were successful, which one failed, and so on. It also provides a very nice GraphQL API. We will talk about that later during the talk. And then you can see down here we have 4 different deployments. What is a Dagster deployment? A Dagster deployment is nothing more than a project like Lorenzo just described. So it's a Python project that has Dagster inside, and basically what this does is exposing a gRPC API to the Dagster daemon and to the Dagit web interface. This gRPC API is used by the two other Dagster components to understand which pipelines are available and in which deployment they are located. So as you can see here, every project is independent. So I don't need to restart the whole Dagster deployment whenever something changes. I will just need to restart the deployment that is affected by my change. And we will see also in a second how we deploy our changes in our developer environment, staging, and production environment. This is the Dagit web interface. Yeah, you should be able to see it quite well. As you can see, it's really nice. I find it really intuitive to see. So you just look at it and you can immediately see which pipelines failed, which one are successful, how long ago they failed, at which steps they failed, which is something that in other tools I found quite tricky or a little bit more elaborate to find. So let's go back to our journey. First of all, when we were evaluating different solutions for workflow management, we of course tested the more classical solution like Airflow. We gave a shot to Argo Workflow, Prefect, and so on. But the winning point in our case for Dagster was this command line that you see here, Dagster new project. This allows you to create a new project with Dagster in a millisecond, literally. So one thing that I struggled a lot when looking at Airflow and Prefect is how should I structure my project? There are 1,000 different blog posts out there with a lot of conflicting information, and there is no standard way of creating your own project. How do you test your own pipelines and so on? And in Dagster instead, this was very, very easy. As soon as we do Dagster new project, my new project, Dagster creates a folder structure like this one that you see here that already has your own folder for your ops, your graphs, your schedules, your sensor, together with tests and all the basic configuration that you need. So with just a couple of commands, you can have a local Dagster instance running, and you can already start writing your code in PyCharm or your favorite editor. The nice thing about Dagster as well is that it keeps your pipelines, ops, and code all inside the same repository. So whenever we change something in our code, it doesn't only test the code itself, but also the ops and graphs that are related to that code. And this is particularly nice because the developer or the maintainer of a particular project not only maintains the code of the project, but also the ops and the graphs that are related to it. And this is very important for reusability because if I am working on project A and Lorenzo is working on project B, let's put it this example, and I want to use one op of project B, all I need to do is a simple Python import, and I can immediately use all the ops and graphs that are refined in his repository. So right before, Lorenzo arrived to the stage where he was testing the code locally, and everything was working fine. But sometimes, especially with the kind of data we deal with, high-resolution satellite images, sometimes it can be tricky to test things locally. This is because our images are gigabyte and gigabyte of data. They take a lot of processing power. They need a lot of memory. And so sometimes there are certain situations in which you just are not able to test your things locally. It's just impossible. It would take you too long. One thing that we've developed recently is the possibility for our developers to request what we call developer environments. This is basically a dedicated instance of Dagster running in our Kubernetes cluster that is that uses only the code that you submitted in the PR. So what our developers do is create a PR to their repository. If they want to test that particular PR in our cloud infrastructure, they just annotate the PR with this label called dev-env. And what will happen in the background is that a GitHub action will create a dedicated Dagster instance with the code that is present in that PR. In this way, if you need to do, for example, performance testing, which is something that is difficult to do in your laptop, if you need to test your pipeline with bigger amount of data and so on, you can do it in this way. Because in this way, Dagster runs exactly the same place where production will run. And this is super nice, and it works quite well. It allowed us to overcome all these little problems that are difficult to test locally. And then what's next? Well, you have a pull request open. Ideally, after some review, it just gets merged, right? So you would merge the PR to master, And in our case, we have a very simple pipeline. So whenever we merge something to master, it gets automatically deployed in our staging environment. And whenever we create a new Git tag, it automatically gets pushed to production. So some people might say it's too simple, might be, but it works quite well for us. Finally, one of the last features I want to talk about for Dagster is the possibility of using also the GraphQL API. So GraphQL is a way of invoking API that is really, really powerful. You can imagine that, as I was saying, the Dagit web interface is just amazing, okay, to start new workflows and so on. But it can get tedious, right? So what happens if I want to run the same pipeline 100 times with 100 different configurations? Well, I mean, of course, I can go there and spend one day clicking around the web interface, but there must be a more efficient way, right? And this is what we can do with the Dagster, with the GraphQL API provided by Dagster. I can define my configuration as code, and then I can just invoke the API to start all these pipelines by code, simply. This is very used for starting workflows, getting status of existing workflows, and so on. And it works perfectly in Jupyter notebooks, which is something that our data scientists very much appreciate. So is Dagster the right choice for you? Well, it depends. I mean, it's still, you still have to think that is a new software. So it has been around for a couple of years, but it's still under very active development. So if you want to give it a try, I very much encourage you to do so. But be prepared because you might find some missing documentation, some missing features, and so on. So you might have to get involved in the community more mature tools, basically, which is not a bad thing, some open source contributions. What I can tell you is that for us, Dagster worked really well. Our developers, data scientists, they like it very much. It helped them, go from a simple Python code or Python script into a pipeline in a matter of couple of minutes. The barrier of entry in particular using this Dagster new project is extremely low, and it's easy to get started. It's easy to build on top of it, and their community is just very, very active on the Slack channel. So whenever you have a problem, there is always somebody to help. We're just a group of very enthusiastic people, let's put it this way. What's next? Well, this goes without saying, but more Dagster, more pipelines, more automation. We are just at the beginning of our automation journey. We have been using Dagster for around a year now. So right now, our aim is to take all the code that we have, take all our Python code, the machine learning models, and so on, and automate them as much as possible. Create Dagster workflow, also get a little bit more acquainted with the software and so on. But yeah, it's part of the process. And guys, we need help. We need help. So Overstory is hiring, of course. We're looking for all kinds of profile. We are a company based in the Netherlands, distributed all over the world. In case you want to apply, overstory.com/careers. I suggest you to put PyCon in the comments of your application. Might help. But yeah, if you have any questions about PyTorch, Overstory, Dagster, myself and Lawrence will be around. We will answer a couple of questions now, but also after the talk, we will be here in case you have other questions. Thank you very much for the attention. And if you have any questions, we will be happy to help.
Right, thank you so much. That was a great talk. We have some extra time from your talk that we can use for questions. So for example, the first one we have is major difference between Dagster and Airflow.
So I don't want to get too political in this. No, I don't know. I mean, it's just a matter of preference, okay? For me, I'm more on the cloud part of thing, not so much on the data science point of, I'm not so much of a data scientist, but more of a cloud engineer. The barrier of entry for me with Dagster was really, really low. It was really easy to get set up. It was really easy to get it running. It was really easy to create my first pipeline, even if I have, not that big knowledge in, machine learning, data science, and so on. Dagster is a tool that is very cloud native. So if you're running on AWS, Google Cloud, Azure, you name it, you can just, use, for example, Google Cloud Storage to store all your logs and all your artifacts and so on. And it's just one setting. You don't need to get crazy with, scripting around things and so on. Yeah, it's just a tool that is built, in my opinion, in a more, cloud native way of thinking.
All right. Also, quick thing. Even if you don't have yeah. Oh, no, there's a lot of questions. So even if you don't have any questions, just upvote the ones you think you should be there. It's like the inverse of Stack Overflow. So next question is, can you run each Dagster up in a dedicated Docker container?
You can. So with Dagster, you have the possibility, you have different executors, they call them, and you have the possibility, for example, to run one op all in the same Docker container. You can run each op in a different Docker container. You can specify how many resources you want each op to have, or you can specify the resources for your whole graph. So you have all kinds of settings you can play with, especially if you're working in an environment with, Kubernetes or things like that. So yeah, and the nice thing as well is that when you run the same pipeline on your own machine, you don't need to have a Kubernetes cluster running. It will just use your Docker daemon. So depending on where you run it, Dagster will adapt and use the executor that you have available in the environment.
We have a short question. It says, easy to use with GPU?
Yeah. That pipeline, for example, being a model that runs an inference, as you saw before, we were specifying in the tags the kind of machine, the kind of resources that we allocate. So we just allocate a different machine that has GPU on it. And then the rest, it's Pythonic. So that's also answering the other question. As a data scientist, compared to Airflow, it's super Pythonic. So as long as you say device GPU and then you run it on a GPU machine, that's it, really. So it's one line of change from standard to GPU volatile that we have in our.
All right, next question. How do you deploy in practice? Using Kubernetes and/or Helm charts, something provided by Dagster itself? And what about spinning up the instances of the node pool itself?
So the Dagster maintainer and Dagster community provides a Helm chart. This is how we deploy it, basically. We have different clusters. So we have like a production and a staging cluster. So there are two completely separate deployments. And the developer environment that I showed you before are deployed in the staging cluster, but they're kept separate from each other. So they're all separate within the same cluster. What was the second part of the question? Sorry, I lost it.
So how do you deploy in practice using Kubernetes and/or Helm charts, something provided by Dagster itself? And what about spinning up the instances of the node pool itself?
Okay, so the instances of the node pool itself are just done by the autoscaler, so the Kubernetes autoscaler. What happens is that as soon as you have a particular pod that needs to go on a certain instance, Kubernetes will create a new instance, let it join the cluster, and then run the operation directly in that particular instance. One thing as well that we developed recently is a custom library that we use only internally to Overstory to simplify this thing. So you have seen before the tags that you need to apply to let a certain graph or a certain op run in a certain node pool. We simplified all that with a library that we built internally so that people just have to say, do you want to run it on a large machine, a small machine, extra memory machine, and so on. And they don't need to remember the instance size, what is available, what's not available, and so on. So just a simple mapping, but it helps our developers.
All right, next question is, can you run each Dagster up in a dedicated Docker container?
Pardon?
Can you run each Dagster up in a dedicated Docker container?
Yes, you can. Yeah.
And then it says, off topic, related to training. How do you assess if a model is better than an older one? How do you score them?
Yeah, it's ideally we have a benchmark data set for the different tasks at hand. So ideally we just benchmark on, let's say, a validation data set that we keep outside of all our trainings. Reality is that we are ingesting all the time a lot of new extra data, so we are revisiting that validation data set. And so that is as long as it goes for metrics. We have an extensive visual QA in place. Metrics are very reliable, but when we need to ship to customers, we need to be 100% sure, because if a team on the ground goes somewhere and finds a mistake, it's not good. So we, on top of the metric evaluation, we also do extensive visual QA. So it's basically a manual process where we examine the outputs of different modules and decide.
All right, that was it. There's no more time for questions, but maybe if you see them outside, you can tackle them and ask them whatever you need. That was Lorenzo and Andrea. Thank you so much for this talk. It was
Thank
great.
you. Thank you.